Alright, so let's get cracking on these questions, lads. First question. Golf course, it's made up of two shapes. You can see it there. One shape, rectangle, then there's a semicircle added on to the end of it. Question 1, work out the distance marked X and Y. We'll start with X. Here's X. Right. It's a radius. We know if we look over here that the length of this side is 50. That means the diameter of the circle is 50. 50 divided by 2 is 25 meters. Y then, Y is from here all the way to here. We know from here up to here, and then another radius added on gives us 300. Sorry. So if we take off the 25 from the 300, we'll get 275 meters. Right. Next question then, work out the total area. Total area, so there'll be two things we have to work out: the area of the rectangle, semicircle. Right, rectangle, 50 multiplied by 275. 50 multiplied by 275 is 13,750 meters squared. And then we're looking for the semicircle, it's that shape. We know that the radius is, 25. So we're looking at a semicircle. I'm going to get the area of a full circle first, which is area equals pi r squared. Fill in your area equals pi, say 3.14, multiply by the radius squared, which is 25. And we will get 1963.49. That's for a full circle though, so we divide by 2. And this will divide this by 2. And we will get 981.7. There's the semicircle. There's the rectangle. We add them together, we get 1472. Alright, they said the nearest square meter, so no decimals. Oh, it's, sorry, not centimeters, sorry. It's 1472 meters squared. Alright. Alright, next one. It says Massey or whatever. Spreading fertilizer over the golf course. Packet of fertilizer has this instruction: 6 litres of fertilizer per 250 meters squared. It says Macy needs to cover this many meters squared. And then it says how many litres of fertilizer will she use. Okay, well, I want to find out how many meters 1 litre of fertilizer uses, because they're asking me how many litres will she use. So I want to find out how much a litre will cover. I know that 6 litres covers 250 meters squared. So if I take the 250 meters and then divide by 6, I will get 41.66 meters squared. So that's what 1 litre covers. I want to know how many litres. So if I take the whole lot, the whole lot of the meters squared that I need to cover, and if I divide that by 41.66, because that's what 1 litre will cover, well, I will get 19,424.904 meters squared. Or sorry, litres. Okay, so that's many litres I need, and they want me to the nearest whole number, so 19,424 litres. All right. Right, next one then. So there is a litre of fertilizer, right? And there's 3 ingredients. Ingredient A, B, C. And they are in a ratio of 1 is to 3 over 2 is to 5 over 3. All right, all we do, okay, we're dividing something into ratios. Okay, we add 3 ratios together. We take then the 1 litre of fertilizer. Well, they're actually talking about milliliters, so it's 1,000 milliliters. So we add these together, All right. And we get 25 over 6. Okay. We take our 1000 milliliters and we divide it by 25 over 6. And that will give us 240. And then we multiply it by this one here, okay, the B, which is 3 over 2. Why? Because we're looking for the amount of milliliters in B. So it's 240 multiplied by 3 over 2. And that gives us 360. And be careful, put in our milliliters. Alright. Okay, this one, nice handy one. We have a cylinder and we're asked to find out its volume. Okay, they've given us everything we need. Right, they've given us the radius, they've given us the height, but they've given us one in centimeters and one in meters. So we just need to change. Them into meters. Why meters? Because look, they're asking for it in meters cubed. So I'm going to change this 90 centimeters to 0.9 meters. All you're going to do then is take your formula, which is volume equals pi r squared h. You're going to slot in what you know. Volume equals pi 3.14 multiplied by the radius, which is 0.9, must be squared, multiplied by the height, which is 4. You multiply it out and you will get 10.18 meters squared, and they want 2 decimal places. Alright, this one, you struggled on this one actually. Most people struggle at it. So let's take a bit of time out. Diagram on the right shows a cylinder. Tank has a volume of that. Right? Tank has a volume of this. So they give us the volume. Volume equals 81 pi over 125 meters cubed. It says the length is 3 times as long as the radius. So we have the radius. They don't tell us what the radius is. Okay, so we just know we've one radius. But we do know the length. So the length equals 3 times as long, so it's 3 radius, 3 radii. It's asking us to work out the radius of the tank. Right, well they give us the volume, so we're going to be starting there first, and it's a cylinder. So it's volume equals pi multiplied by radius squared multiplied by h. Let's fill in what we know. And we know the volume, 81 pi over 125. We don't know the radius, but let's just leave it as radius squared. Multiply by, we don't know the height, but we know that it's 3 radii. Okay. And actually, apologies there, lads, I forgot to put in this pi, so multiply by pi again. Okay, right, let's just start working it out. Bit of algebra, 81 pi over 125 equals 3r by r squared is 3r cubed multiplied by pi. Okay. Oh look, this is great. We have a pi on this side and a pi on this side, so we cancel them out. So we're left with 81 over 125 equals 3r cubed. Stabilizers, need to get rid of this 3, so we divide by 3, divide by 3. Okay, I'll just keep it as a fraction. So this side divided by 3 is actually 27 over 125. And this side divided by 3 is r cubed. Now we need to cube root this side, okay, to get rid of that cube. And we need to cube root this side. Right, and what we'll actually get then is r equals 3 over 5, that's in fraction form. And if we change it into a decimal, it's 0.6, so 0.6 meters. All right. Right, next one. So this here, right, it's like a cage. Say it's a framework for a greenhouse, and they're asking us how what the minimum length of wood we need to use to make this frame. It says give your answer in the form a plus b pi. What that means is it kind of makes it a bit easier on us, right? You just need to load the language. So they're asking us to give us a number there, but the bit that's stuck onto the pi, we just leave it as a number pi, right? So it'll make sense when we go through it. So let's start adding up, right? So we know this bit is 4. So 4 plus, we know that's 4. So another 4. We know this is 4. And we know this is 4. We also know this is 8. We know this bit here is 8. And we know this bit here is 8. Right, so if we add up all them, we get 40. Okay, and it's meters. So now we have to look at this curved bit. So this curved bit here is essentially a circumference of a circle, but only a quarter of it. So circumference of a circle equals 2 pi r. So we get the circumference of the whole circle, right? Circumference equals 2 multiplied by pi. We leave it as pi. Why? Because look, they're allowing us leaving it as pi. Multiplied by the radius. Well, look, the radius is this, which is 4. So the circumference equals 8 pi. But that's for the whole circumference. That's the whole way around. We're only looking for a quarter of it, so we divide by 4. So we get 2 pi. But there's also another quarter here, so we multiply that by 2, and we get 4 pi. So we have the 4 pi, and we have the 40. So it's 40 plus 4 pi meters squared. I suppose we should put a meter squared here as well. All right. Then it says calculate the total volume of the space enclosed within the greenhouse. It's quite handy. Volume, so it's volume equals pi r squared h. Okay, we know the dimensions. So volume equals pi. We can leave it as pi because it says leave your answer in terms of pi. Multiplied by the radius, which is 4 squared, multiplied by the height, which is 8. And if we work it all out, the volume equals 32 pi meters cubed. Okay, so this one, they're asking us to find the net. The net means we just fold it out. Okay, so let's go. We know here it's 9 centimeters, and each of these blocks stand for a centimeter. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's the base I'm drawing here. Now you draw it with a ruler when you're doing it. We'll go the other triangle. Okay, so it's 3, yeah. Okay, so if we look at it over here, it's 1, 2, 2.5 up. So 1, 2.5 up. So it's there. Draw that. Then if we look at this side, that will fold out here. So it's 3 this way. Okay. And then 3 this way. Okay. And yeah, that's kind of it. Okay. Next one then, nice handy one again. Watermelon, so it's a sphere. So a sphere, sphere is volume equals 4/3 pi r cubed. Give us the radius. Radius equals 20 centimeters. And they're saying leave our answer in terms of pi, so please do. It's saying cut it into 16 pieces, and they're looking for the volume. Okay, so we have the volume formula. Throw in what we know. Volume equals 4/3 multiplied by, leave it as pi, multiplied by the radius, which is 20 cubed. Okay, if we work all that out, we will get, going to leave it as a fraction, but you don't have to. So it's 32000 over 3 pi. Okay, so that's the volume. You could put it as a decimal if you want, right? But that, I'm going to leave it at that. But we're asked for the 16 piece, so we're just asked for one slice. So we divide that by 16. Okay, and we're left with 2000 over 3 pi centimeters cubed. Or 666.6 pi centimeters cubed. But that's a nicer answer. Alright, but this will get you your marks too. Okay. Next one. So it's telling you what to do. Use the theorem of Pythagoras to work out the value of L. This is this bit here. So I will draw a triangle, 12, 5, and L. So this is our hypotenuse here, and then our opposite and adjacent. Okay, the opposite and adjacent doesn't matter in Pythagoras' theorem. So we have h squared equals a squared plus o squared. Fill it in. H squared equals 5 squared plus 12 squared. And if you do it all out, you'll get L squared equals 169. And root both sides. And you get L equals 13. And it's 13 centimeters. Okay, they'll dock if you don't put in the centimeters. So there's your answer. And they're looking for the total surface area. Total surface area. Well, curved surface area. So we'll call it curved surface area equals pi r L. L standing for the slant height. Okay, that's the curved surface area. But remember, there's a circle on the bottom, so plus, and a circle is pi r squared. Fill in what you know, throw it into your calculators. It does say correct to one decimal place, so it's 282.7 centimeters squared because it's area. And there we go. Right, I'm not going to do it all out for you. You should be able to do that. Okay, so the same thing. So look, the same cone, here it is. And they're just asking us to give the radius of the circle and the circumference. So if we take this up here, just take a mental note of that, right? So the radius is 5. So radius is 5 centimeters. Circumference, you find the circumference by doing circumference equals 2 pi r, and r, remember, is 5. So you will be getting 31.4 centimeters. All right. This bit here then, okay, this essentially is, if we cut this cone and started folding it out, if you remember I did it in class, I cut it and folded it out, what would it be? Well, the radius of the sector, so this bit here, and that's actually the slant height of the cone. Look here, you cut it. Okay, so slant height of the cone if you folded it out. We got that already, that was 13 centimeters. All right, and then the length of the arc, which is this here. Okay, well, remember the length of the arc, right? If you can picture that cone, okay, that cone, if we just fold it around, this arc here is actually the same as the circumference of the circle. So again, that's 31.4 centimeters. All right. All right, next one, a bit of geometry. You need to know something for this, okay, which I taught you, which is this and this add to 180 degrees. Remember, okay, always opposite angles in a quadrilateral, okay, add to 180 degrees. So by that logic, we can say 3x plus 10, that's this bit, plus 2x plus 25 equals 180 degrees. Look at that, one equation, one unknown, just the x's. We can solve that quite easy. So we have 5x plus 35 equals 180. Okay, if you want to do your stabilizers, minus 35. minus the 35, that will give us 145. So 5x is 145 divided by 5, and we'll get x equals 29 degrees. This bit is similar triangles. Hardest bit in this is just to match up which side relates to what side. Alright, so let's try, okay, let's see now. Okay, so let's look at, see this angle here? That has two stripes, okay, so that matches to this. So if we look at the line that connects this angle here with the two arcs and this angle here with the one arc, that's y. Okay, so let's look at it over here. What would y relate to on this smaller triangle? Well, look for the line that connects the one with both arcs to the one with one, and it's 5. So we can just say y equals 5. I'm just going to put it up here, right? It doesn't really equal 5, right? But it matches. Okay. Y matches to 5. All right. Now look for the one that comes directly out of, let's say, the single arc. Okay, so it'll be here. So x matches to 10. And the leftover one then, 6, matches to 8. Okay, so now we can do our similar triangles, or our ratios. So we can put one over the other. 6 over 8 equals, and I don't know, we'll take anything we want. We can put x over 10. If we cross multiply, we get 60 equals 8x. Divide by 8, divide by 8. We get x equals 7.5 centimeters. So there's x. Yeah, we do the same with the other one. 6 over 8 equals 5 over y. Okay, we take this one. Cross multiply, we get 6y. Okay, that's that way. Equals 5 by 8, which is 40. And then divide by 6. So y equals 6.66 centimeters. Okay, let's keep going. Similar triangles again. All right, well, similar triangles are transversals through lines, whichever you want. But let's have a look at, well, it says DF and EG and BC are parallel. That means these here are all parallel. Okay. So that would mean, see the 72 here? Well, x, that matches to x. Look, this is x and this 72 are the same. So x will be 72. If we look for y then, which is here, well, look, here's a triangle. See it? We know that the triangles in a triangle add to 180. So if we take the 72 plus the 28, take it away from 180, we'll be left with 80. So y is 80. And then z here, which is this. Well, watch here. I know that x, okay, is 72. Try and rub it. Just tidy this up a bit for you. Right. So I know that this x here is 72. And look at here. Here's a straight line. Yeah, so I know that this bit here would be 180 minus 72, which would give me 108 degrees. Why am I wanting to find that? Because I know that this z is the same as this here. Okay? Again, I'll just rub it out, tidy it up a bit for you. So I know that this angle here is the same as this angle here. I'm already after telling you or finding out that it's 180. So if that's 100, if that's 108, then that's 108. And we'll make sure to put in our degrees because we don't want to lose any handy marks. Okay. Now it says, explain why the two triangles ABC and ADF are, first of all, similar. So ADF, so this one, and ADF, sorry, and ABC. And ABC is the big one. So why are they similar? Well, they're similar because they have the same angles, all same angles. So watch, just tidy it up. So this angle here, well, that's the same for both triangles, isn't it? It's the same for this one, and it's the same for the big one. So if we wrote angle the same, this X one here, that's the same as this, and this Y one here is the same as this. So we're asked why are they similar? Because they've all the same size angles. And why are they not congruent then? Congruent triangles are the same angles, same size. If you remember, it had to be side, angle, angle, or side, side. Okay, but remember we said congruent triangles had to be the same. So if you were to say angle, 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 all three angles were the same, that wouldn't necessarily mean they're congruent. Okay, so what can I say for that? Mind, we won't put that in our answer. Okay, I'm just showing you why they're not congruent. Just say because not the same size triangles. Okay, right, now next one we have a question of similar triangles. Right, we're saying work out the length of GE. GE is here. Right. So, okay, how will we do that? Well, I'm going to take it in two triangles. I'm going to take this as one triangle. Look, the bit I'm highlighting here. Okay, I'll just draw it. Fill in as much as I know. I know it's 20. Why? Because it's 10 plus 10. I don't know what that is though. Okay, this side here. That's what I'm actually looking to find. And if we take the other triangle, the bigger one, just this, we just draw that. Well, I know this is 14.3, and I know this side here is 30. Why? Because it's 10, 10, and 10. 30. Okay, now we have two triangles. They're similar, same angles. One is bigger than the other. We can do our ratios, which we use for similar triangles. So we match up the sides, the 20 and the 30, for example. Okay, so we say 20 over 30, and then this one here, so equals 14.3. We put x here because we don't know what it is. Cross multiply. So it'll be 30x equals 286. Stabilizers again, divided by 30. Divided by 30, we get x equals 9.53. Just look back at our question. Do they say give it to one decimal place or anything like that? No, they don't. All right. Right. This one's saying work out the value of x. There's a lot of kind of stuff there to confuse you, right? But just have a look at this. This is the right angle triangle here. We have two sides, this and this. So straight off, if we can identify its Pythagoras' theorem, h squared equals a squared plus o squared. Okay. Here is the hypotenuse. So it's 15 squared equals the a squared. It doesn't matter which we say a and which we say o is. So we just say the 9 is the a squared plus the o squared, which is what we're looking for. So look, we call it the x. All right, and 15 squared then is 225 equals 9 squared is 81, and we don't know what the x squared is. Take 81 from both sides, and then we will get 144 equals x squared. Square root both sides, and we'll be left with 12. So x is 12. Okay. And then it says use similar triangles to work at the value of y. Right, we'll tidy this up a bit. Okay, similar triangles to find out the value of y. Okay. I know, don't know if I need it, but I'll just fill it in. I know the length of this side now is x plus x, and I know the length of x is 12. So that's 24. Okay, so I might need that. Right, similar triangles. So, well, it says similar triangles. They must be similar triangles. So if we just match this right angle with this right angle, I'm going to start drawing. So I'll draw the big one. Okay, we fill in what we know. Well, there's y. There's 24. That's all I know about the big one. And the small one, I'm going to just flip it so that the right angle is over here. Okay, and I know then this is 15. And this is x, which is 12. Okay. And I also see that this is 9. Right. So, well, let's match them up. The y matches with the 9. So we put the y on top, the 9 on the bottom. The 24 matches with the 15. So the 24 on top, 15 on the bottom. Okay, we cross multiply. We 15y equals 24 by 9. So I'm using the calculator. 216. Divide by 15. Divide by 15. We get y equals 216 divided by 15 equals 14.4. Okay, doesn't say if it's centimeters or not, so we'll just leave it. Right, next one. So this is some trigonometry. We have a right angle triangle, so we know straight off this trigonometry. We're going to be using either Pythagoras' theorem, or we're going to be using the could a hungry stupid ostrich have taken over America thing. So look, could a hungry stupid okay, it's not working. Could a hungry stupid ostrich have taken over America? Remember, I said to write this down straight away. Okay, because if you don't know that, you're going to be in trouble doing any of these trigonometry questions. It says the diagram shows a ladder leaning against a vertical wall. The ladder is 225 centimeters high. That's 2.25 meters. The ladder is safe to use when the angle y is marked 75. So if this angle here is 75, then it's safe to use. So we have to find out what that angle is, essentially. Just get your triangle if you want. 70, 225. We want this angle. Okay? So first thing you do, write this down, which we've done. Second thing, label your sides. So in relation to this angle, the hypotenuse is always the longest side. There it is. The opposite is always the side opposite the angle we're talking about. The adjacent is the one left. Okay. What two sides do I know? I know the length of A and I know the length of H. So H equals 225 and A equals 70. So I'm dealing with H and A. So H and A. Which one do we take? Well, there's A. There's H. So it's this one. So it's cos we're dealing with. Okay. And cos is the adjacent over the hypotenuse. Okay. We're looking for the angle. So if you remember that little internal joke we had, we press shift. So it's shift, cos, and then we're looking to put in the A on top and the H on the bottom, okay, with our fraction. And when we do that, we get 71.89 degrees. Okay. So, is that 70 degrees? No, it's not. So we will just say not safe. Next one. What is the height of the ladder? What is the height of the ladder can reach up? What is the height what is the height the ladder can reach up the wall when it is in a safe position? Well, it's only in a safe position when it's 70. Okay, so that has to be 70. Okay, this will still be 70 centimeters. Okay, so we have 70 degrees here. That's when it's safe. it's still going to be 70 centimeters from the wall, and we're trying to find out how high up does it go. So if you can imagine, this here is oh, sorry, actually my fault. No, that will change. The ladder won't change though, so which is this here. So the height of the length of the ladder won't change. The ladder is always going to be 225 centimeters. Sorry about that. Right, so now we've a triangle. We have one side, we don't have the other, but we do have the angle. So again, we're looking at this: could a hungry, stupid ostrich have taken over America? So could a hungry, stupid ostrich have taken over America? We're going to label our sides. We label them, so in relation to this is our opposite, this is our hypotenuse, and this is our adjacent again. Now, what side do I have? I have the length of h. What side do I want? I want the height it goes up, so I want this, and that's the opposite. So now I'm dealing with h and o. So h and o is sine. So it's sine of 70 degrees equals, and then we have the o, which we don't know, which is x, but we do have the h, which is 225. So find out what the sine of 70 degrees is first, and it's 0.939 equals x over 225. We're going to have to multiply this side by 225 to get rid of it. We'll have to do the same with the other side. We'll be left with x equals, and it's 0.936 multiplied by 225, and we will get 211.275. So that's the height that the ladder will be up the wall when sorry guys, I'm just after seeing there, I'm after misreading this, so rewind. It's not 70 degrees of an angle, it is 75 degrees of an angle, so apologies there, I need to go back. This question here is still okay. Why? Because we got 71.87, so that's not 75 degrees, so it's still not safe. Okay? Where I made the mistake was here. I said 70 degrees. It's not 70 degrees. Okay? It's 75, so sincere apologies. We'll go back over that. So it's 75 degrees. So all that means is, this is all grand, right? But it's not sine of 70 degrees. It's the sine of 75 degrees. So it's 75 degrees. And check out what the sine of 75 degrees is. Sine 75. And it's 0.09659. Okay, we're still dividing by the 225 and 225, but now we're multiplying it by 0.9659, and we get 217.32. Okay, centimeters. If we divide that by 100, we get 2.17 meters. Okay. Apologies about that 70 and 75 degree mix up. Right, next one, we're looking for A. There it is. I'm just going to draw the triangle. Right, we'll use the small one. Again, it'll be trigonometric ratios. So we're looking for A, which is here. We know that this is 5. We know this is 1.55. We're looking for an angle. It's a right angle triangle. So we're using, again, could a hungry stupid ostrich have taken over America? Hey, so let's start labeling our sides. Well, in relation to A, this is our opposite side, this is our hypotenuse, and this is our adjacent. So what two sides do I have? I have the opposite and I have the adjacent. Okay, opposite and adjacent, we're dealing with tan. We're looking for an angle, so we'll press shift. So it's shift tan. The opposite is 1.55 all over the adjacent, which is 5. If we throw that into the calculator, we'll get 17 degrees. So A is 17 degrees. Then it's find the height of the mast, which is this here. Do it a few ways. You could use similar triangles if you wanted, or you could use tan. So it doesn't really matter. I suppose, look, seeing as we're doing trigonometric ratios, we'll continue using the tan, I guess. Yeah, sure, why not? So we'll sketch the big, basically it's this triangle, the big one. We know that's 17 degrees. We know the length is 5 meters here and 18. So 5 and 18 is 23 meters. But we don't know this. Okay. And we have a right angle triangle. We're looking for a side this time. We can't use Pythagoras' theorem because we don't know the length of the third side, or sorry, the second side. So we'll have to use trigonometric ratios. Again, we're looking at using this. The could a hungry stupid ostrich have taken over America. Let's label our sides. This is the opposite, this is the adjacent, this is the hypotenuse. What side do I have? The adjacent. What side do I want? The opposite. Opposite and adjacent, we're dealing with tan. So it's tan of 17 degrees equals, the opposite is on the top, so it's x all over 23. Right. If we press the tan of 17 degrees, let's try it. Tan 17 equals, we get 0.3057 equals x over 23. If we multiply by the 23 on this side to get rid of it, and we multiply by the 23 on this side to get rid of it, we'll have x equals, and then it's 0.3057 multiplied by 23, we get 7.03, and it is correct to 1 decimal place, so it's actually 7.0, okay, meters. I know it's a bit messy. 7.0 meters, which is the same as 7 meters. Okay, we'll keep going. Okay, I'm not going to do this one for you, but I'll explain it. So it says John and his friends know that as they move towards the mast, right? So look, just tidy it up a bit for you. So as they move towards the mast, the angle of elevation from the top, or sorry, from the ground to the top of the mast increases. That's true, right? Let's say if John moves this way, okay, and he stands here. Well, the angle is going to be steeper up to the top of it. Okay? And if he moves in here, it's going to be steeper again. One of John's friends believes the following. So he believes that if the angle of elevation is doubled, the horizontal to the base of the object is halved. So let's say John is here, right? And the angle of elevation is, I'm going to make it up, right? 20 degrees. And from here, where he's standing, to here is 18. Well, if the angle of elevation doubles, so let's say he moves in to here until it's 40 degrees. Okay? So that means the 20 doubles to the 40. Well, then what he's saying is that 18 from here to here actually halves. So he's only 9 out as opposed to 18. Okay, so what you can do is you can draw that out with your compass and with your protractor, etc., and see if that's true. Okay, they don't give you much room, by the way, but look, if you can't. Okay, we're getting there. Here, work out the angle of C. Right, I'll just sketch the triangle that we're working with. So it's this. Has to work out the angle of C. Okay, you could do a lot of, complicated-ish maths, using trigonometric ratios, etc. There's no point though, because we know that this is a right angle triangle. We know it because we have a right angle there, so that's 90 degrees. And they tell us this one is 35. So if we add them and take them away from 180, we'll get this. Why? Because this and this and this is the three angles of a triangle, and they must add to 180. So 90 plus 35 is 125. And take that away from 180 and we get 55 degrees. Next one. Mary works out the horizontal distance between the two buildings is 154. Okay, so look there. Right, so we're given that. Just tidy this up. Okay, let's just see what we're being asked. It says use Pythagoras' theorem to work out the distance marked y. Right, distance marked y. Pythagoras' theorem. Yeah, look, that's easy enough, right? Because we have this, so here's our triangle. So we'll sketch it. 220 and 154. Now sketch 220 and 154. Right, label your sides. O, and then A and H doesn't matter. So it's H squared equals A squared plus O squared. Fill in what you know. So H squared, we don't know what it is, we're looking for. Rewind, I labelled wrong. Okay, labelled wrong. Okay. So this, the hypotenuse, is the longest side. And the O and the A doesn't matter. So we've H squared equals the A squared, in this case is 154. The O squared is 220. We square them all. And if we work it all out, okay, square them all and get the H squared, we get an answer of 268.54. And we were asked the nearest meter, so just make sure you read the question. So it's 268 meters. Meters, not meters squared. Okay. Next, it's telling us what to do. Use trigonometry. Okay, so straight away, could a hungry, stupid ostrich have taken over America? And we're looking for the Z. So let's see where Z is. Right, Z is here. Okay. I'll just again tidy this up a bit. Okay. Right, well, remember, these trigonometric ratios, trigonometry, only works, well, from what we've learned, it only works on right angle triangles. And this here, this bit here, look, is not a right angle triangle. So we can't just take the Z as a whole. However, we know that this here is 220. So this is 220 from here up to here. So if we just forget about that, right? We're going to get the length from this bit to this bit. Okay, we can do that because look, we have a right angle triangle here. And then we can add this 220 on then to get the Z. So let's just fill in what we know here. We don't know this, right? So we call it X. If we can find X and we add 220 onto it, then we get the length of Z. Do we know this side here? Look, this. Yes, we do. Because we know this is 154. So that's 154. And this is 20. So we'll sketch this. 20 and 154. So 154 20 degrees. Let's fill in now what we have. Well, sorry, we label it first. H, O, and A. O is always opposite the angle we have. Now ask yourself, what side do I have and what side do I want? Well, I have the A, which is 154. I don't have the O. O and A, well, O and A we're talking about tan. So it's tan 20 degrees equals the O is on top. So it's O, we can call it X, right? Just so we don't get confused with 0. And 154. Stabilizers, multiply by 154. Well, actually, sorry, rewind. Yeah, I'm going too quick myself here now. The tan of 20 first. So tan of 20 degrees, 0.363. Okay, equals X over 154. Now we'll multiply by 154. Multiply by 154. That'll leave us with X equals, and 0.363 multiplied by 154 equals 55.90. It says to correct to the nearest meter, so 56 meters. But remember we've done all that good maths. Okay, 56 meters. Wouldn't we be tempted now to just say, yeah, we're done? But we're not. Because if you go back up, remember, we have to add this 220 to it. Okay, to get the whole length of Z. Look, that's what we were asked for. The length of Z here, which is the whole length. So we have to add 220 to that. Okay, so it's 56 plus 220 equals 276 meters. Next one then, coordinate geometry. Remember the x value comes first. The x axis is the horizontal one. Right, so A is here. I think you're well able to do this, right? But let's do it anyway. So it's 3 minus 2. And C is here, and it's 0, 1. Now it is B, D, and E are 3 more points. Plot and label the point B, 4, 3. Okay, so it's 4, 3, so it's up here, and we label it B. This is awkward now that I have to keep down and up. ABCD is a parallelogram. Use the information to plot and label point D on the diagram on the previous page. So we have to plot another point to make this parallelogram. All right. Okay. So parallelogram means that two sides are parallel to each other always. So let's take this one, the B to the C. So that means if we went down here, they'd be parallel, wouldn't they? So we go yeah, it's kind of awkward, but anyway, we go down 2. So watch, to get from B to C, I go down 1, 2, and then I go across 1, 2, 3, 4. So let's do the same here. 1, 2, 1, 2, 3, 4. So there we go. Okay, and does that work? Yeah, because look, if we join this and join this, we have a parallelogram, and that's point D. All right. Point C is the midpoint of AE. So point C is the midpoint of AE. Write down the coordinates of E. So we want to write down the coordinates of E, and C is the midpoint of AE. So C is the midpoint of AE. Right, tidy this up a bit. Okay, so C, there is the midpoint, look, of A, E. So E is somewhere up here. If it's the midpoint, then the distance from here to here will be the same as from here to here. So I just have to ask myself, what do I have to do to A to get to C? And then I'll do the same from C to get to E. Well, I go across 1, 2, 3, and I go up 1, 2, 3. So I'm going to do the same from C. I'm going to go across 1, 2, 3, up 1, 2, 3. There we go. So E is minus 3, 4. There it is. E is minus 3, 4. They want us to write down the coordinates, so it's minus 3, 4. Let's keep going. Right, another coordinate geometry. Write down the coordinates of point A and C below. So A, we know it, it's minus 3, 2. C is 7, 1. Show that the distance, look, remember we talked about it, these two lines mean the distance. So the distance of AB is the same as DC. So distance, so we're talking distance formula, all right? So straight away you're opening the logbooks, you're getting your distance formula, which is distance equals x2 minus x1, all to be squared, plus y2 minus y1, all to be squared, and then we square root the whole thing. Essentially, you can use Pythagoras' theorem as well, I guess, okay, but let's not. Right, we're going to find AB first. That's why I'm splitting it, and then we're going to find DC. We're going to label our points, so let's do the AB first. So A is minus 3. I'll do it out here. They really don't give you enough space. So A equals minus 3, 2. B equals 4 and 7. Right. We have the formula down. Let's label our points. X1, Y1, X2, Y2. Fill them in. D equals square root of X2, which is 4, minus 3 squared, plus Y2, 7 minus 2 squared. Okay, that minus will become a plus. If you throw that all into the calculator, you'll get the square root of 74. You can leave it at that, because when you go over here to do the same, you're going to be using points C and D. You're going to be putting it into the same formula, and what you'll get is the square root of 74 again. Okay, so I'm not going to do it all for you. Show that AD is parallel to BC. Parallel lines have the same slope. Yeah, so find the slope of AD, find the slope of BC. So again, you're going to do the same. You're going to split it. Slope formula, y2 minus y1 over x2 minus x1. Yeah, that's the slope. M is for slope. You're going to get AD this time. So go up here, AD, minus 3, 2, 0, minus 4. Minus 3, 2, 0, minus 4. Label them. X1, Y1, X2, Y2. Put them into your formula. Y2, so it's minus 4 minus 2 all over X2, 0, minus 3. Minus 4 minus 2 is minus 6 over 3, which is a slope equals minus 2. Okay, and if you do that again over here, but this time you take BC, and BC will be 4, 7 and 7, 1, and you do the exact same, well, you will get a slope again of minus 2. And that means parallel lines have the same slope, and do they have the same slope? Yes, they do. So I would write to the side, therefore, look, if you do 3 dots like that, it stands for therefore in maths, therefore parallel. Let's keep going. Show that the midpoint of AC is equal to the midpoint of BD. Again, we're going to do the same. Look, split it. This is midpoint now, so it's x1 plus x2 over 2, comma y1 plus y2 over 2. Right, and we're going to find it for AC, and we're going to find it for BD, and we're going to see if the midpoint of AC is the same as the midpoint of BD. Okay, so let's do it. AC, well, A equals minus 3, 2. Minus 3, 2. C equals 7, 1. Label our sides, label our points x1, y1, x2, y2. Slot it in. So x1 is minus 3 plus x2 is 7 all over 2, comma, y1 is 2 plus y2 is 1 all over 2. Minus 3 plus 7, well, you know your rules. Okay, when the signs are different, we subtract the numbers and use the sign of the bigger number. So we get 4 over 2, comma, 2 plus 1 is 3, so we get 3 over 2. We can leave it like that. Okay, we do the same over here on this side. Write down your formula. Label or put down your sides, which is BD. BD in this case is 4, 7, and 0 minus 4. I'm not going to do it for you, but you're going to put it in. You're going to do the exact same, and you're going to get 4 over 2 over 3 over 2. Okay, so you're after showing it. Last thing, everyone wants to prove that ABCD is a parallelogram. Based on parts 1 and 3, state one fact that proves B, C, and D are parallelogram. Right. Parts 1 and 3. Parts 1 and 3. Well, here's parts 1. Right, so this is 1. So we've showed that the distance between AD and DC are equal. So we can write that down. Okay, we can say A, is it D? AB and DC are equal. So we can say A, B equals DC. Okay, so they're equal in length. And part 3 is definitely about the slope. Let's say not the midpoint. Okay. Okay. And we can say that midpoint of AC equals midpoint of BD. We're just kind of rephrasing it. Okay, so we can basically say then the opposite sides are parallel to each other. Okay, we can say the diagonals bisect each other. We can say the opposite sides are equal in length. Okay, so if you just say opposite sides equal in length, that will work for you. So watch, look, AB and DC. Let's have a look at them. AB and DC. If we drew it, which we will, ACB, which is 4, 7. And 0 minus 4. Okay, so look, there's our parallelogram. So we can say that this here, the one I'm doing in red, is the same length as this. Okay, and we can say this is the same length as this. Right, and that will get us our marks. Nearly there, guys. Bear with me. Right, same again. Last question. Write down the coordinates of P and Q. P is 2, 3. Q is 4 minus 3. We want the slope. So we're finding the slope. Do you know what I'm going to do? The rise over run here. Right. So I'm going to start on Q and I'm going to see what I have to do to get to P. So I have to run negatively. So if you remember your rise over run. You could use your slope formula, y2 minus y1 over x2 minus x1. That's fine. But it's just quicker for me to do it this way. So how many blocks do I have to run to get right under P? 1, 2, 3, 4. So I have to go minus 4. And how many then have I to jump to get back onto P? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that equals minus 3. So it's a slope of minus 3, I think. Okay, so slope of minus 3. It's negative. Okay, it's going down the way. And, well, the reason, it's going down the way, right? So look, the slope of PQ is going down the way. Remember we said any slope going down the way is negative. So even if we just said slope going down, that proves it's negative. Diagram shows line L and points A and B. Given the equation L equals 2x minus y plus 5, find its slope. Okay, so we're given the equation, find its slope. Remember, handiest way is using the formula y equals mx plus c, with m standing for the slope. So we just kind of jiggle this equation around. Okay, we can use our stabilizers if you want. We leave my minus y here. We'll take away the 2x. Okay, we want just y on the left, just the y's. So we take away the 2x. We'll be left with minus 2x on this side. If we take away the 5, we have 5 on this side, so we'll have minus y equals minus 2x minus 5. It's a minus y though, so I don't want that. We change the signs. Y equals 2x plus 5. So what's the number in front of the x? It's 2. So the slope equals 2. Right, next one. A equals minus 1 minus 3. B equals some number k, 3. If the line segment AB is parallel to the line A, calculate the value of k. All right. Here is what I do here. We're talking about slope anyway, right? Why? Because it's parallel to line L, and we know the slope is 2. Okay, so here's what I'm going to do. I'm going to use the slope formula, okay, which is y2 minus y1 over x2 minus x1. Now I know that the line segment AB is parallel to line L, and the slope of line L is 2, so I know that. Now let's start filling in the y2, y1, x2, x1. So A equals minus 1 minus 3. B equals k, so I don't know the number yet. I'm going to find it, 3. Right, fill in what label our points. Y1, or x1, y1, x2, y2. Start filling them in now. So y2 is, we don't know, it's k. Right. Minus y1, sorry, my fault. That's too late. Back again. Right, y2 is 3. Minus y1 is minus 3, so it's minus 3. Over x2 is k, minus x1 is minus 1. We can tidy that up, it'll be 3 plus 3 over k plus 1. And that equals 6 over k plus 1. Right? So, again, they really don't give you much space, but 6 over k plus 1. That equals the slope, which is 2, isn't it? Okay. This k plus 1 is not nice. We need to divide by it. Divide by k plus 1. Or sorry, multiply by k plus 1. Let's get rid of it. Multiply by k plus 1. Okay. I'll do it down here, guys. It's getting really messy. They're just not giving enough space. So 6 over k plus 1 equals 2. Right. I want k on its own. That's the whole point of this. Okay. This k plus 1 underneath, we need to multiply by k plus 1 to get it out of here. We need to do the same on the other side. This will leave with 6 equals 2 multiplied by k plus 1. 6 equals 2k plus 2. Minus the 2, and we're left with 4 equals 2k. Divide by 2, and we're left with k equals 2. So k is 2. Nearly there. Write down the coordinates of A dash, the image of point A under axial symmetry in the x-axis. Right, so we're looking at x-axis. We're looking at point, what is it? Okay, well, let's sketch it, right? We'll just tidy up this a little bit. Okay, pity they didn't give us a graph, but we can still figure it out. I'm just going to sketch my x and y axis over here. And point A is minus 1, minus 3, right? So 1, 2, 3, minus 1, minus 2, minus 3, 1, 2, 3, minus 1, minus 2, minus 3. Right, so A here is minus 1, minus 3, so it's there. And they're saying write down the values of A dash, the image of A under axial symmetry in the x-axis. So axial symmetry means we bring this point to the x-axis and we bring it the same distance up here. So I have to travel what? 1, 2, 3 to the x-axis. That means I have to travel 1, 2, 3 the other side. So there is A dash, and what's the coordinate? It's minus 1, 3. A dash equals minus 1, 3. And the last thing then is investigate if A dash, which is this, which is minus 1, 3, is on the line L. Well, let's see. Where have we an equation for the line L? We do. Look, here it is. 2x minus y plus 5 equals 0. 2x minus 5 plus 2x minus y plus 5 equals 0. We want to find if this line is on, if this point, minus 1, 3, is on line L, which is this. So what we do is, we take our x number, we put it into the equation, we take our y number, we put it into the equation, we work it out, and if at the end it says 0 equals 0, then it is on the line. If it says something else equals 0, then it's not on the line. So here we go. 2x, we put in the minus 1, minus y, we put in the 3, plus 5 equals 0. 2 minus 1 is minus 2, minus 3, plus 5 equals 0. Minus 2, minus 3, plus 5, well, that is 0, equals 0. And I will say, therefore, minus 1 say minus 1, 3 is on the line L. And guys, that's it. I went quick through that now, right? There's an hour and 14 minutes. I went very quick through it. You are not expected to just watch this the whole way through. Okay? You won't. I don't think you'll understand. You need to pause it, go back over. Like, this should take you 3 hours. All right? So really put in a big effort now in correcting this. All right? Okay, thanks, guys.